get the recording. And again, welcome. Our topic today is fish passage. Just to highlight, we have Dave Stewart with ODF&W. He's a fish biologist, and we'll go ahead and let you get going, Dave.
All right. Thanks, Rachell. Thanks everyone for joining tonight. As you can see, we're going to do an intro to fish passage, and I'm going to zip through. I've got a number of slides. This is kind of I guess, a little bit broader presentation. So as you can see from the photo here, this is actually, I thought this was fitting for a fish passage project, even though this isn't in Scappoose. This is part of the Klamath Dams removal. So I think pretty exciting to finally see that work go on. We're actually going to be heading down there in a couple months to meet with some of the partners there. But just kicking this off, this is kind of a good view of before and after. The goal here on fish passage is obviously removing structures. And I'm going to talk a little bit more about how that works, some of the law, the regulatory, and the process. And I think John is going to get into a little bit, take this conversation a little bit further as we go here. So yeah, here's a little bit on the overview. We'll have some time for Q&A at the end, but basically, again, policy, history, passage issues, overview, and we're going to talk about triggers, exemptions. I think all this is important because it lets everybody understand really why the law is there. And there is, with ODFW, really our only authority, kind of one of our few authorities is fish passage. Other than that, we really don't have much authority. We kind of work with other agencies to comment, but fish passage is one, and I'll talk a little more about that. And I think it'll also help everybody on here to, as you're out there in the field, understand, maybe if you're talking to people, to understand about the law and kind of how it works. And Rachell, just on this as I go through here, is it good to, are we going to kind of take questions more at the end of this? Is that how we're going to do this?
Yes, that is correct. We take all of the questions at the end.
Okay, perfect. So like I said, I'm going to zip through some of this. Again, we have a fish passage program. I'm, Dave Stewart. I'm in the North Willamette Watershed District. So the way ODFW is broken up is we have our headquarters office, which is where the fish program is, and then I'm kind of more at the district level, so the North Willamette, which includes Scappoose. But when we have projects that need to get reviewed, approved, some of the higher level technical projects go to Salem, and we have a team there of coordinators and folks that are helping us implement those. And so this is just a good idea. I mean, it gives you a perspective of the challenge, right? And so this is known fish passage barriers in the state, and probably, it isn't all of them, but just gives you a perspective, like, current levels. And this is like everything. So, there's a lot of barriers up there. We see this all the time, almost, every month you're out there in the field and you run across some low head dam, a structure, whatever it is. And you're like, wow, that wasn't even on our wheelhouse. We didn't even know about it. So we've been doing our best to categorize all these, and we have a fish passage priority list, which actually is getting published kind of as we speak. So there will be a great document, the updated document, which shows all the priorities from number one all the way down the list. And there's a couple in, this in Scappoose, which we'll probably talk about tonight. And so here's just a little bit on the numbers, right? I mean, tens of thousands of structures, and you can see with the photo. I mean, this is the challenge, right? Salmon trying to go over some sort of a low head dam and just basically run into this, can't make it, and then they're forced to spawn in subpar habitat potentially, right? So we want to remove these barriers. We want to make it easier for people to get up. And I'm going to show you a couple of little shots of what this looks like out in the field. So again, a culvert here, and you can see, so jump height is one problem, right? You got a culvert that at some point when it was put in might have been flat, and now you see it as it's actually a height where a salmon can't jump up. And I'm not going to get into too much of the technical as far as how much of a height and how much of a jump, but essentially, for juvenile fish, we're talking inches. That's the max. For adults, it can be a little bit bigger, but essentially we're trying to reduce these jump heights and these velocities. And here's just some photos of what this looks like around. And you can see, obviously, we've got different types of projects, whether that's low head dams, tide gates, undersized culverts, bridges, you name it, but there's tens of thousands of these out there, like we showed. And then, and again, so here's some of the problems. I love the upper right corner fish with the chum. I think that photo's been out there a while, but it's pretty classic to show, what the challenge is. These salmon are literally running into concrete structures, human influence and they're being impacted and they're not able to reach, their spawning habitat. And that's kind of the goal for all this fish passes is how do we get the fish from, they're coming up to the ocean. How do we get these salmon up into the most important habitat? Some of those are in the upper watershed, right, where they're spawning. If they can't get there, that's a problem. And I'll just jump around again. Some of these are more regional around Oregon, so you get an idea of the perspective of different types of structures that are out there. No fish passage, right? We have a lot of these that are out there where there's zero passage and there's tens, if not hundreds of miles of habitat upstream. Gold Ray Dam, some other shots, some other irrigation diversion. I think this one on the Crooked River has actually been removed. And I think there are steelhead back in that area. Water diversion structures, perch show these undersized culverts, and you can just see the challenge, right? Velocities, jumps. These are the problem. I think when some people come up to these structures, they don't realize the challenge. And even if there isn't a jump height, just the velocity of getting into these pipes, essentially, it's like a fire hose, right, at certain flows, and the fish can't migrate even if there wasn't a jump height. And then tide gates, and this is one we were talking about today, and so there's these massive tide gates where there's lots of prime time habitat within the lower Columbia that fish can't access because for this situation there's flood control. There's farmers upstream, and we're trying to reduce impacts to the ag land. So those are some of the challenges, right? I mean, you can imagine the amount of habitat that's upstream of these. How do we find solutions for situations like this where you have a tide gate? And so I'll get a little bit into, I don't want to go too deep on this, but just kind of the fish passage law, the language, right? So artificial obstruction, we talk a lot about that. So it's any dam, diversion, dike, anything we've seen here that is placed in the water state that precludes or prevents the migration of native migratory fish. Pretty straightforward. And these are the causes that we're talking about. We've seen some of these, right? Water velocities, water surface, jump heights are too high, structural supports in the channel, whether that's levees, dikes, shallow water depths in the receiving pool. Fish need a certain amount of depth in the pool to jump. So if those are shallow pools at the base, they can't get up. Abandoned structures, and the list goes on and on and on. Attraction flows, when you're talking to dams and spillways, fish, when you can imagine, and I've got a great photo at the very end of a passage that you guys, I think everybody's seen much of the time, but it's interesting to talk about attraction flows because fish come up to these dams, and if you don't have the attraction flow to a fish ladder, then they can't find the ladder. They're not smart enough. So that's another problem. And in Scappoose, we have some of those as well. So just going right back to the start. And again, I think folks don't always realize this, but we've had a fish passage law since essentially before statehood, right? So this is kind of what it said back in 1848. And the challenge is that, we really haven't enforced it, or we didn't enforce it very well until recently, right? And so it's always been there, but now we do have a law, ORS 509.585. You can look these up and look at some of the language there, but essentially it gives ODFW and the state the ability to enforce fish passage. And a little more here what this looks like. So it's a mandate. Requires us to maintain a statewide inventory, which I talked about. That's that fish passage list and the priority list. And really the idea being is that finding cooperative partnerships to remedy the fish passage, right? It provides us authority to review and approve. And there's some other authorities we have around waivers and exemptions. But essentially the idea being, I mean, we do have the authority to do some pretty heavy-handed things, but for the most part, our number one thing is to work with partners. And that's why the Watershed Council, Waterways Consulting, all the partners we have are so critical, because there's no way ODFW could implement and do a good job without all the partners. So that's a little bit on the law. Again, some of this is going to be kind of repetition, but we have this fish passage criteria, which we'll talk about here in a bit. There's a task force that meets regularly and reviews and approves parts of this fish passage. They've just, like I said, they just approved the fish passage priority list, which everyone can see. There's a draft copy right now online. And also owners and operators must maintain adequate fish passage. So you can't, if you're out there in the field and you see a structure, a passage, a culvert, something that's failing and not maintained, that's actually against the law. And so we can actually go to those owners, operators, and require them, to fix it or work with them to fix it. Here's a little bit on species. So a mix here, but this is a big part of fish passage because not all fish are created equal. Some salmon, steelhead can pass differently, whether it's a lamprey, but these are some of the high priority species you hear about, right? Bull trout, suckers, lamprey, sturgeon, pike minnow. But for, I think, Scappoose, we're talking a lot about coho, Chinook, steelhead, cutthroat, different species there. And that's a big part of this. So, Rachell, are we doing okay here? Any questions or anything?
No, you're doing great.
All right. So this is kind of where the authority comes in, and again, I think it's good to know this if you're new to the fish passage law, because it tells us what we can do, right? So if there's any new construction on a stream that's affecting fish passage, that is our authority comes in there. If there's a change to permit status, right? So at dams, relicensing, right? That's a typical change in permit status where we would come in and we would review that. And that's where you see some of these bigger projects like Klamath dams that we saw at the start, or some of these other bigger projects where they have to come through relicensing. We get at the table and we say, well, you have these options. You can provide passage, right, which is a lot of times create a fish ladder, or you can maybe just remove the structure. And I think some of these areas like Klamath, I think other areas around the state, it makes more sense, cost benefit sort of thing, to actually remove the structure completely. And then also you can't abandon an artificial structure as well. That's also against the law. So, but the trigger events, we talk a lot about this because this is really important. This is when there is a trigger. So essentially there could be structures out there that are not providing great passage, but there isn't a trigger yet, right? So undersized culverts are typical ones. So if you have I'm going to talk about active channel a bit, but if you have an active channel width, by law, the width of the structure has to be at least that big and a little bit larger. But we can't go in necessarily and just tell somebody to replace that. There has to be a trigger, right? And so this is all these numbers show you, is that, for example, at dams, 30% cumulative excavation or changes in the structure over time triggers fish passage. Tight gates, 50%. And so this just gives an idea of bridges. So if there's a lot of work done over time, then it allows us to come in there and actually let the owner operator know that there is a trigger. And here's some of those, right? New road culverts, widens, extends the road. So we deal with the counties and the municipalities a lot on this, right? Where they're doing some of this work, and then there's a trigger to fish passage. We come in and help them implement a project. And like I said, 50% on the bridges. So there is a part of this where there is some enforcement authority, where it is needed, and so we do have that. But like I said, we attempt to try to work with everybody, and that's why we're here tonight, trying to share some of this. And so here's really what it comes down to when you're trying. I think John will probably talk a little about this, but there's two alternatives that you kind of have here. When you have a trigger, you have to meet passage. We'll come out and say, hey, if you're going to meet fish passage, it has to either meet the stream simulation design approach, or you can kind of go through the hydraulic design. And a lot of the stuff we do is stream simulation. And this is kind of what it looks like, right? The idea of it with stream simulation is you have a project, you have a new structure there that creates an environment where the fish essentially don't know the culvert's there or the new structure's there. We want to simulate essentially what a stream channel is. And here's an example. The one on the left is what it was before. You had an undersized pipe, a drop. It was way too small. And the fix is a bottomless arch, culvert. And you can see stream simulation that met the active channel, which is 1.2 feet or 1.2 times 2 feet. And then here's a little bit more on that data. So the width, this is the new criteria. So, and I'll show you the active channel a little, but essentially it has to be 1.2 the active channel plus 2 feet. It's got to meet the same slopes, water depths, and kind of all those details. And here's a little bit just more on that, maintain the water depths. And there's a whole process. I'm not going to get into the deep part of that, but just so you realize the stream simulation is a very common, and that'd be a good question again for John when he gets in to talk about what percentage of projects do you work on that are kind of stream sim versus using the hydraulic. But here's what active channel, sometimes there's some confusion here between, active channel width, bank full width, things like that. But essentially active channel is that, and I'll show you a little bit sketch here of it. It's the kind of the ordinary high water line, or that mark the channel gets up to kind of regularly throughout a given year, and so this is kind of what it looks like, right? So you've got the bank full terrace, which is a little bit wider, and then you've got the active channel margin. So it's not necessarily the wetted channel, but it's that active channel kind of during that normal winter flow. And so what you would do is you would measure these over a certain period of time. You'd get that active channel average. You would take that number, you would multiply it by 1.2, and then add 2, and that would be the criteria. So you can imagine as you go around, a lot of these culverts are undersized. It's very common to see old culverts. I'd say probably most of them are undersized. And I talked about that. There's also some other criteria. Again, we're not going to go deep on this, but talks about vertical clearance and meeting certain criteria for the structure. We've seen this actually happen in nearby. I'm not sure if we've had any problems like with this in Scappoose, but in the Claskenai where culverts have not had the right clearance, didn't have the right slope, that were designed, not properly. I'm not going to get into that whole part, but where you have culverts that essentially fill up and there's problems, and then you have a whole nother passage project. So you spent, hundreds of thousands of dollars in these projects, then you have an issue you have to come back and deal with. We want to avoid that on projects. And here's one, just another kind of what that looks like. And then you also have, so that's stream simulation, right? Going back to that, that's, basically you can see this channel doing our best to simulate the natural channel. There's also the hydraulic method. And so this is where you can actually utilize this based on the hydraulics and the hydrology of the system. And it's based on, the species that are present that you have to meet the criteria for. So like I said earlier, there's different velocities, different max velocities for certain species. And there's different jump heights, which I said at the start. Again, if you want to know some of these details, we can go in deeper, but just so you realize that's part of the criteria. And, but essentially natural-like solution. So we do some other things, rock weirs, roughened channels. These are all fish passes. So it's not just metal structures. It's not just culverts, bridges, fish ladders, things like that. There's actually other design projects that we kind of work with. And then here's, and John, you might also know, some of these are pulled off from the North Coast, so these might even be some projects you worked on. But maintenance is also a big part of this, right? So you have to maintain your structure once it's completed. You get big flood events, things change. So the owner operator is required by law. And we have that when we do a new project. We'll come back at regular intervals to review and see how things are looking. You can see the woods kind of mangling up these arrays that they have on the head of the pipes here. And so this will be, I'm just going to jump into the approval process, because I think that people listening, just so you know, if you do have a project you're interested in, there is a process that I'm here to help with that. And so typically what we do is we'll get a call from somebody. There might be a trigger. There might be a, Watershed or somebody that says, hey, we've got this landowner that really wants to fix this thing. Or maybe there's even a washout or something. So we go up there, we'll, like I said, go to the stream. We'll take some average measurements to determine the active channel, and then we'll utilize that to make a determination on what size you'll need to have for the structure at a minimum. And of course, you can always go bigger than the 1.2 plus 2 I talked about. And then, and that's what Rachell does so well. And John, then we bring in the pros, and they start finding funding and put together a project. And this is our fish passage. This is a very simple document. It's just a few pages of fish passage plan. This gets filled out. I get a copy of this, I review it, make some notes, maybe make a site visit, and then we make a determination, give that active channel, and then we kind of take the next step. Some more shots of some rough and channel, things like that. And I also want to, before we get out of here, I just want to share also that there are a few other options. These are not options that we use that often, but basically there's 3 options for fish passage by law. One is to provide passage. That's what I've talked about most of this presentation, is that's the one we really like to see, because, we're fixing the problem. Fish are able to eventually get past this area. That's a win, I think, for everybody. The challenge is sometimes, these projects are not always cheap. So they take time to, to get the funding for them. But the other 2 options are either getting a waiver or an exemption. And so as you see here, fish passage waiver, you can actually mitigate. So if you, for some reason, the landowner, owner, operator couldn't provide a passage for whatever reason, they can actually go through a process to try to get a waiver from ODFW. There's a whole, depending on the amount of habitat upstream and the type of habitat and all that, there's a whole process. It might have to go through the commission and the task force and things like that. But essentially there is a process, and you can mitigate. The other thing is, the other option is to go for an exemption. This one is definitely much harder to get. I've actually never done a fish passage exemption, although they are, you can, there have been a few out there, but so that's another, and so this would be where you'd actually do the work, do the surveys to actually show that there's no habitat essentially upstream, no appreciable net benefit to providing passage. So if you're in a situation, you can imagine the extreme would be, it's hard to think, but you imagine a site that just has almost no habitat upstream. There's no spawning habitat, there's no rearing habitat, there's nothing. Maybe it's in the middle of a city or something. So that'd be one example. So there are a few options. So again, these are just throw it out there to complete this presentation, but providing passage is what we're shooting for. And I just want to leave it with the photo I mentioned at the start, which is, I think this is a great one because if you go back there right now, Celilo Falls is obviously under not that much water actually right now. It's right there, but I love this shot because it shows you how impressive that natural falls, and maybe someday we'll see that. So, but this is behind the Dalles Dam, of course. So, another structure. And if you look at the bigger picture, right, you've got the Snake or the Columbia River and all the dams there and all the passage. And so, so we're not quite at this scale, but again, I think that's a good one to leave it off with. And that's all I got, Rachell. If you have, do you want to hold questions till the end here?
Yeah, we typically hold questions till the end. Thank you so much, Dave. And then that was very informative and so wonderful. Thank you, Dave. And just give John another quick introduction here. John Dvosky, he works with Waterways, and he has done a number of projects and assisted with the designs and also helping with the project management of them in the area. Most recently, we worked together on the Grabhorn property, doing the bank laybacks there with a contractor, and we are actively planting that project now. And John, are you ready to do your presentation?
Sure. Thank you, Rachell. So I was going to talk about the engineering aspects of projects. Let me share my screen here. Hopefully everyone can see that. There is going to be some overlap with what Dave talked about. So I apologize for some of the repeating. It's not too much overlap, but obviously we're talking about the same types of projects. I'll go into a little bit of depth about the design aspects. I'll start now. So design aspects of fish passage. As Dave was showing, a lot of the projects he was focused on, and it's not all the project, but it's quite a few. And if you kind of looked at the map where he showed both the prioritized passage barriers throughout the state, but then also the sort of unprioritized ones that people kind of know are there, but they're not evaluated in detail and included in the prioritization. You'll notice, at least in Eastern Oregon, where they're not as dense, they look like they exactly follow the transportation corridors. And that's because most of our fish passage barriers are associated with transportation infrastructure. But in general, almost all the barriers are associated with some sort of infrastructure. And, Dave alluded to that. Levees, roads, of course, dams, and that could be different kinds of impoundments, water diversion structures, all sorts of things that are integrated into infrastructure. So when we're replacing or addressing the fish passage, it usually requires replacing that infrastructure, or at least modifying it to a certain extent. It also means that the projects are inherently public works projects. So, Dave alluded to the fact that they're fairly expensive projects, and it's because they're public works projects. They're roads, they require engineering design, Obviously, you have to go through the full suite of permits that are required for these types of projects. So they're not always simple projects. They often are associated with utility corridors. There's properties that are adjacent to them. There's easements. In some cases, you have to acquire new easements to do these projects. So they're fairly complex and they get fairly expensive. In terms of the professionals involved in these types of projects, there's often licensed surveyors, civil engineers. There's also geotechnical engineers to look at subsurface conditions for foundations. There's designing those foundations, that's structural engineering. Hydraulic engineers to make sure that we're both protecting the public when we're putting in these new structures, and also it's meeting the design criteria. Biologists are involved to, map wetlands, look for T&E species, all those kinds of things. Sometimes in certain settings, there's landscape architects if they're in, more built up environments, and people want to, make the final product look nice for a built environment. And then there's, of course, people that specialize in permitting that are involved. So it takes a lot of different professionals to get even some of the smaller projects through the whole process. And then that doesn't also include the contractor, lots of heavy equipment and things like that to get these built. So the project costs can be significant. But I will say, despite those high costs, fish passage projects are often the most cost-effective restoration alternatives. I've been involved in a lot of planning, watershed scale planning level projects where we identify restoration sites that would improve fish habitat at a watershed scale. And then we go through a prioritization process, and usually the fish passage projects float to the top because in a lot of cases, as Dave mentioned, you're spending a lot of money maybe in one location to address that passage, but you might be opening tens of miles of habitat. And if you do a site-specific restoration project where maybe you, enhance floodplain locally, you could spend a lot of money, but it's really only influencing that localized area. So fish passage projects are often kind of what we consider the low-hanging fruit for restoration. The project types, Dave went into this, but I'll reiterate. They come in all shapes and sizes. And it really requires a site-specific evaluation and design for each of those different locations. And then you also have to address the needs of multiple stakeholders. The types of projects, this isn't exhaustive by any means, but the road crossings are the most common. Those are the ones we work on the most. But there's different types of road crossings. One is creeks and rivers, so riverine crossings. Those are kind of the standard ones where you might have a culvert that it's undersized or perched, and you replace that with a bridge or a bottomless arch culvert or something like that. But there's also on roads, there's crossings in tidal environments that may have tide gates on them. And those tide gates are maybe protecting upstream land uses from flooding. So, those are the ones that are challenging to deal with. There's also hydraulic structures that may be limiting floodplain access. So that might be a levee that has a tide gate on it, or a levee that doesn't, but it's preventing fish from getting to accessible habitat. So those are also kind of quasi-passage type projects. There's diversion intakes. Those could be diversion dams. There's also seasonal push-up dams that you get a lot of those in Eastern Oregon and Southern Oregon. Tends to be more rural areas, but they might not be year-round passage barriers, but when they want to divert water, they don't have a structure in place to build up the grade of the river to push water into their intake. So they get an excavator out and they push gravel up, and it creates a seasonal barrier. There's also impoundments, so large dams. Those can range from large dams to small impoundments. Some of them may have fish ladders on them that were built a long time ago and they don't meet current design criteria, so they still represent passage barriers. And then there's recreational dams, and those tend to now be remnant structures, but they're still present in the landscape. And they don't always present, they can present seasonal barriers, and in some cases they can present barriers for juveniles migrating in the summer to try to find cold water refugia, for example. Or they could represent barriers for both adults and juveniles. Here's a few example photos of these different types. It's not exhaustive in any means. This obviously is a pretty dramatic example of, it's hard to see the highway. There's so much fill that filled the entire valley, but there's a highway up here. And this, when it was built, obviously it wasn't built perched like this. The downstream area and size and the head cut moved upstream, but this is about 10 feet drop here. And a survey was done on this pool, and there was hundreds of juvenile coho. And this is a very cold water refuge tributary to a larger river, but the fish are only able to use 10% of the available cold water habitat because of this barrier. So removing this type of barrier, even though it's millions of dollars to address, would open up 6-7 miles of cold water refuge habitat for coho. So a pretty important site. This site here, this is a diversion dam, and it's low head. So in the winter months, it doesn't represent a barrier at all. It's backwatered. But in the summer months, this section of creek actually dries up. So juvenile fish need to be able to leave this area and move upstream to the perennial headwaters. And when flows get low, they can't do that. So hundreds of fish get stranded in this pool here. And these are steelhead primarily. And so removing this barrier would greatly benefit those juvenile fish. This is an example of a push-up dam. This was at the end of the diversion season. They removed it for us to be able to survey. But this one's interesting in the respect that not only is there a diversion on the creek that flows from right to left in this photo, there's a diversion intake over here, but there's another diversion that comes off. This is the Applegate River, comes off the Applegate River, runs parallel to it in a canal, and then it crosses this tributary. So this addressing passage here needs to deal with two different diversions and water rights and all that kind of stuff. So it gets complicated, but this gives you an idea of what this a push-up type dam, a seasonal push-up dam looks like. This structure here, this is actually at a ODFW fish hatchery. And so it's a diversion intake that the hatchery uses to provide water for the fish hatchery, but it represents a passage barrier. So addressing that would be important and would open up, I think, about 8 to 10 miles of habitat upstream. This is a road crossing. I think attempts were made in the past to build a structure that would backwater the actual culvert, but further, additional incision downstream moved up, and then it created a barrier for the fix. So there's a big drop right here before fish can move through that culvert. And then this is an example of Dave and I worked on this together. This is a remnant flashboard dam structure at a county park on a tributary of the Clackamas. And it only represents a seasonal barrier, so it's only a low flow barrier, but it's one of those things that it was prioritized to remove to provide, the free flowing condition. So how do we address fish passage? Like I said earlier, it really depends on the site. It's very site specific. Depends on what's going on upstream, what are the adjacent land uses, what the barriers, what's the reason for the infrastructure to be there that's creating the barrier. As Dave mentioned, ODFW and NOAA Fisheries, they've established a set of passage guidelines to address fish passage. It usually requires completely replacing the existing structure because most are undersized. The design has to consider channel geometry, but it also has to consider flood capacity. There's, county regulations that say, you have to provide 100-year flood capacity plus freeboard. You also have to consider sediment moving through the system and also debris, so large wood and things like that. And some of the ODFW regulations get at some of those requirements for freeboard to address large wood and things like that that are moving through. Dave mentioned the stream simulation versus the hydraulic design approach. Obviously, the preference is stream simulation. It often performs better, and it's preferable to design that way because, as Dave mentioned, the hydraulic design approach, you have to meet certain very specific criteria on water depth, velocity, that are kind of independent of what's going on in that overall creek reach. Whereas the stream simulation, if you're matching what's going on upstream and downstream, then there's less of a focus on those hydraulic conditions. The design criteria that's established for the hydraulic design method, there's depth and velocity criteria, but they're very specific for both juvenile and adult fish. So you have to meet all those criteria. In some cases, you can get variances if you're having a hard time meeting those criteria, but the preference is for you to meet all the criteria. The biggest question when it comes to designing, and it also affects whether you're doing a stream sim or a hydraulic design approach, is the discontinuity between the upstream channel and the downstream channel. And if there's a severe discontinuity, like that one photo I showed you with that very high perched culvert, it's sometimes hard to meet the stream sim approach because to meet the stream simulation approach, one of the main criteria is that you match the kind of reach scale channel slope, so the equilibrium slope. So if you go quite a ways upstream, you come up with an elevation, and then you go downstream, you do a longitudinal profile. You want your final channel to be roughly in conformance with that reach scale channel slope. And if you have those big discontinuities, it's sometimes really hard to do. Fish passage at tide gates is also really challenging. And that's primarily because the tide gate is there often to protect upstream properties from getting inundated during high tide conditions. There are some technologies that have been developed, but they haven't been perfected, that allows the tide gate to open and close depending on the elevation of the water. That it does it passively without having, electrical systems and things like that to open and close it. But those technologies haven't been perfected, so they're promising, but there's still work that needs to be done on those. And then the other challenge that comes with the design is the FEMA regulations. And this goes back to this discontinuity because in some cases, to address the discontinuity, you want to bring in channel fill to address the fact that a lot of material might have been mobilized downstream of the culvert, which is creating that discontinuity. But if you add material to the channel and it's in, for example, a FEMA regulated floodplain, it's hard not to raise the 100-year water surface. And so that's become a real challenge in a lot of projects. So addressing this discontinuity, I'll kind of get into the details on that, but there's multiple ways to do it. One is to remove the structure and just let a head cut that had developed migrate upstream. And in some cases, it's irresponsible to do that because if there's properties upstream, for example, and you release a head cut upstream and the channel incisors, you can exacerbate bank erosion and things like that. And you likely wouldn't want to do that if there was adjacent property owners upstream. It could also cause incision that would impact habitat conditions upstream. If there was a well-connected floodplain, for example, you may not want to incise that channel and disconnect that floodplain. So that one has been done, and I'll show you an example, but it's not always the preferred option. Another option is to split the difference. So this is the big culvert I was showing you on the opening slide. And this is the upstream profile, channel profile, and then you can see the road fill here. And then there's the big scour pool at the downstream end, and then this is the channel profile downstream, and then it meets the confluence of the larger river down here. So splitting the difference, what you do is you cut material up here, and then you fill material down here, and the desire is to make it balanced so that you're not having to import a lot of material. But as you can see in this example, we're not able to balance. So in this case, we have to bring a lot of material to the site to fill the downstream channel so that we end up with an equilibrium slope all the way through this entire reach. So that's a solution that we've proposed at this site. And the channel slope here, so I think the equilibrium slope is 4.2%. Our channel through here that we want to put in, this Highway 3 culvert is being replaced with a bridge. It's a spanning bridge, so we don't even need to worry about the influence of that bridge on the channel. So we just focused on restoring the channel, but we end up with an approximately 4.5% channel slope through here. So it's slightly steeper than the equilibrium, but within the range where it's an acceptable compromise. And then the last one would be, approach would be to completely build the stream bed downstream to match the upstream channel bed. And of course, that requires bringing in a lot of fill. And I'll show you an example of that on a diversion dam that we did recently. But again, it's very site specific in terms of what the solution might end up being. When it comes to diversions, and this also applies to other passage barriers, but there also is kind of a philosophical and cost consideration when we look at different options. For a diversion structure, for example, or a diversion dam, there's kind of a continuum of different approaches, some being hydraulic approach, which is highly engineered, and then others being a science-based geomorphic approach. And so those range from fish ladders, which people tended to do more frequently in the past, but we're finding now that the fish ladders are problematic. Dave talked about getting fish to be attracted to the fish ladder as opposed to the rest of the flow that's coming over the dam. There's also the challenge with sometimes the fish ladder only being accessible and passable during certain flow conditions. So people have sort of veered away. They're also actually fairly expensive to install. Kind of going down the list of the hydraulic approach, drop structures. So these are kind of, it's like a fish ladder, but it's a concrete set of weirs that spans the entire channel and kind of builds up the channel up to the height of the diversion or the dam. So fish can kind of move up, one step at a time, but it's full channel spanning. It can be pretty expensive, but it addresses some of the the hydraulic issues that people have discovered with the fish ladders. And then there's a rough and channel approach, which tries to build up the channel by mimicking a riffle. So sometimes people call them roughened riffles or constructed riffles. They tend to be less expensive than the drop structures of the fish ladder, and they're closer to a geomorphic approach, but they do represent a hydraulic approach because they're often steeper than the upstream and downstream channel conditions. The next is a restored profile. So you remove the dam, but the downside of this is if it was a gravity flow diversion, often you have to go to a pump diversion because you're not holding grade anymore. And then the last one would be restoring the natural channel bed completely. So those are kind of, like I said, increasing ecological function, going from the hydraulic approach to the geomorphic approach, but there's pluses and minuses to each. The rough and channel is an approach that's becoming more and more popular. People are using it. It tries to resemble, a riffle. So there's lots of large rock extending from the channel bed, which provides nice hiding spots for fish as they're kind of moving up this maybe slightly steeper section of channel. They could support aquatic organisms like insects and things like that, and they tend to function for both a juvenile and adults for a range of species. So people like them a lot. In cross section, they kind of look like this, so they resemble riffle. You can also integrate pools into these rough and riffle structures. You can put large wood, so you can kind of mimic a stream channel. So going to some examples, so this is an old diversion dam that people weren't using anymore, but the structure was still in place. Historically, flashboards were placed in here to divert water. And because it wasn't being used anymore, and because there wasn't any residential land uses or any concerns upstream, the approach taken here was just to completely remove the dam structure. And there wasn't a lot of grade difference between downstream and upstream. It was fairly small. So we were able to just remove the dam and then let a small head cut move upstream. And these are the photos downstream of what it looks like after the fact. So it's very much a restored channel bed after the dam was removed. So that's the ideal situation, but we don't always have the opportunity to do this where it's an unused structure. Usually the land use continues to be that they want to divert water there. So something like this, there's a dam in place, there's a diversion structure up here, you can see it. And they want to continue to use that diversion structure. They have to hold grade to allow water to go into their diversion intake. And so in this case, we built a roughened channel structure that essentially buried the dam. So you can't see the dam anymore, but the dam is actually still there. And this roughened channel is about 550 feet long, so fairly long, but it creates sort of a mimicked riffle and allows fish to freely move up past this historic barrier. So that's, I think I've gone over my 15 minutes, but if you have any questions, I'm happy to answer them.
Yeah, thank you so much, John. That was a really, really good presentation. And then I just wanted to reiterate to both of the presenters, thank you so much for taking your time to present. I will just be putting up a very quick presentation and then we'll open it up to questions. First, I just wanted to share in the chat the link to the storyboard that our lovely GIS technician, Sophie Verdorn, put together, and then I'm going to share it and we will talk about some of the fish passage barriers and the work that the Watershed Council has done since we became a Watershed Council. One moment. All right, and so I sent you all the link. So you it is open to the public. You're more than welcome to open and look at this. These partnerships with ODF and W and Waterways and all of our partners are so important to the work that we do. It's how we get so much work done. And so to reiterate, since the Watershed Council was formed in 1997 and in 1999, we conducted a study to prioritize the fish passage barriers. The study identified 107 artificial fish passage barriers, and since then, the council has removed 46 fish passage barriers, correcting the 15 highest ranked barriers in the watershed. And these efforts over the course of the Watershed Council has led to reconnecting over 50 miles of salmon spawning habitat. And then just to look, this map shows the 1999 fish passage priority ranking. And then you can look at the work that we have done since then. This is an updated 2025 map that includes the green, includes all the projects and corrections that we have done, correcting each of these barriers looks different, just as both Dave and John talked about. And then also many of these projects are not just a fish passage barrier removal. We normally will include during this project large wood placement for spawning gravel retention and pooling, creating those cool water retention pooling for juvenile salmon habitat, as well as we'll do invasive species removal and native riparian planting after we have done the corrections that we have done. And so just to go down and talk about a few different types of the projects that both Dave and John talked about. This is Dark Creek. To start, actually, it started as this very undersized culvert that was definitely perched on one side. And through efforts, it, became an open bottom culvert, and that created better habitat for salamanders and lamprey and other just other habitat so that, you know, giving that stream bottom and making that much wider. And so that was one type. And then to go to another type of project is Brush Creek. I'm more familiar with this project. This started as a culvert here. And we replaced that culvert with a large bridge to allow for easier access for fish. This included 1.5 miles of large wood placement, which was over 200 logs, as well as a large riparian native planting in the area. And then Cedar Creek was a project that was completed in 2012, and this is kind of hard to see, but where my cursor is a culvert, and it's kind of clearly very small and undersized, and brush and vegetation is growing over it, and it kind of collapsed, and it was no longer functioning, and so that was removed completely, which again is that ideal goal when we can do that, and it created much better habitat. And I will stop sharing. That was the extent of just a snippet of the work that we do here at the Watershed Council and continue to do. We continue to want to prioritize fish passage wherever we can, work with landowners and municipalities and all of our partners with the soil and water conservation districts in order to, and ODF and W, and our engineers to get all these projects moving when we find them. So at this time, I just wanted to open up the floor to any questions that anybody may have. And Dave Stewart in the chat shared where you can find the fish passage priority list and inventories. Oh, and Andy, it looks like I saw your hand first there.
Yeah, hey, let me see if I can lower my hand. I just wanted to ask, like Dave and John, and I think Rachell to some extent, I think you hit on a really important thing, Rachell, when you talked about that, you know, sometimes we approach these projects from a fish first perspective, but we often find benefits for other species down the road, right? Like throughout the process or after. And I guess my question is, you know, Dave or John, so like, I guess full disclosure, on my day job, I work on wildlife connectivity policy across the West here in the United States, trying to advance resources that help move more projects along, both aquatic and terrestrial. One of the really interesting places that I get to think a lot about is where the opportunity for aquatic and terrestrial connectivity sort of meet, and the thing that they always seem to meet at are potentially culverts. So, you know, you may approach aquatic connectivity issue, and it speaks to one size culvert in terms of correcting the issue. But then if you think a little bit about it and maybe apply some other lenses, you may find that if you like increase the diameter slightly more, all of a sudden now you're increasing capacity for deer or elk or other larger species, which then from like a council perspective could open up that project to additional funding, more diverse funding, right, as a way to help do more work. And I'm just curious, as you're coming onto a project site, are you guys starting to think about those opportunities and where, hey, if we actually did this thing, it may help with this other aspect of connectivity or habitat restoration that then kind of expands the purpose, meaning potential support for the project?
Yeah, Yeah, I think hey, Andy, that's a good question. I think I would say that I did in my presentation talked about, you know, providing, you know, culverts and new bridges and things like that. But really the first question that should be asked when you get to these sites is, can we remove it all together? You know, there's some areas where we might potentially be able, it might be an old road. And if we can just take it completely out of the picture and not put a structure, just open it up, lay back the banks and just have it open. I mean, that's the first thing, you know, and secondly, I think bridges are always kind of our first choice when we can. Sometimes they're more expensive, but I think a bridge typically is going to have a wider span, allows more movement of the channel. And then after that, I mean, I talked about 1.2 plus 2 as our criteria, but the federal criteria is, you know, a little bit larger, and we always try to get as large as possible. You know, I mean, that's the goal. It's just every foot you increase obviously increases costs. But yeah, and there's other species too, like you mentioned. It's not just the salmon, it's the wildlife, all those other critters that are out there. So yeah, I'm not sure, John, if you have any, or Rachell, if you have any feedback, but that'd be my take, is that I think complete removal is the preferred if we can do it, but not always possible.
Yeah, I haven't thought about it specifically. I mean, I'm not really a expert on knowing, you know, what a wildlife corridor needs to look like. You know, if that requires a lot of floodplain, for example, that you'd have to integrate. But I do know that, you know, we do a lot of projects where we're starting with an alternative analysis and we're looking at arch culverts versus bridges. And I mean, we're finding now, especially with some of these bridge manufacturers that do these modular foundations and things like that, that the bridge isn't really costing that much more than the culvert. And in some cases, they're very equivalent, because when you start getting into larger and larger culverts, the height of those culverts increase. And so you have to provide cover over the culvert, you know, for something to drive over it. So it might be 2 feet of cover. So at that point, you might be raising the road prism for long distances one way or the other. And if it's a paved road, for example, that can get really expensive. So it's not always true that the culvert is going to be the cheapest option. And I agree, like the bridge is far and away the better solution. I mean, especially for debris and sediment and things like that come through. And you know, you could get a 30-foot span on a bridge and a 30-foot diameter culvert, and you're going to get way more capacity with the bridge. So yeah, I think maybe thinking about that from a funding perspective, and maybe there's a factor you would use to say, hey, even though the bridge is 10% more, let's go with that because there's a benefit to these other wildlife species.
Yeah, that's a great point, John. And that's something you could do in the process, is actually a lot of the funding we talk about comes from OWEB and groups that are focused on salmon, right? Not salmon and trout and steelhead. But if you had some other funding sources that focused on these other wildlife species, you know, you could bring in the money and then go to your landowner and say, hey, we got this extra money. Let's make this thing huge, right? Like John's saying, let's go big on the bridge. That's a possibility.
Yeah, I think you both covered that question really well. Thank you. Jim, Brick, it looks like you have a question.
Yeah, thanks for the presentation. I've enjoyed it so far. The council's replaced a lot of culverts, like you mentioned, since 99 or whatever year it was. Do you have a sense? Is this something that maybe you guys are interested or in the works of re-examining your current fish passage list, maybe adding additional culverts that nobody knows about, that maybe somebody knows about that's not on the ODFW list? And if that's the case, then I would encourage you to also think about it. You know, as ODFW updated their fish passage list, one of the things they recognized that was really important was to add climate criteria into it. And so that's something that I would also encourage you, if you kind of re-examine and reprioritize your list, is to think about how those climate factors might play into your prioritization method.
I completely agree, Jim, and we are looking at reprioritizing the list and really looking at what needs to be done moving forward and doing planning. We're reviewing, the board is also assisting with that and reviewing our SAP, but I agree with you on that climate lens of really like looking at that climate lens and like looking at where maybe culverts are that weren't historically an issue, but maybe that opens up cold water. So I think that that is also really important. We're also looking at future partnerships that will give us access and looking at furthering, you know, temperature sensing and water quality monitoring, at least temperature wise throughout the watershed to really like look at, you know, finding where that cold water is within some of these systems as well that wasn't previously thought about.
Excellent. Thank you.
And then did anybody else have any questions?
Hey, Rachell, as I threw another little comment in there. John showed the Eagle Fern project. This is on the Clackamas, but it's a 7-minute video that one of the landowners put together on that project. It kind of shows the whole, kind of what we talked about, quick little video. So for those that want to take a look at that one.
And that is very awesome. Thank you so much, Dave. We will get all of the links and this presentation once because it was recorded. We do post these to our YouTube video. So we'll get all the links together and this video as well, and we'll send it out to everybody so that everybody has all of those links to be able to review. All right. We'll give it just another second.
Hey, I had a question, maybe going back to you, Jim, since you're still up there. What do you think would be, given where we're at? You know, we got, I think, I'm not sure who's all on here, but probably some board members and folks like that. What do you think would be looking at the Scappoose? You know, next time we've talked about some projects that are, you know, potentials and stuff like that. How would you explain the planning, since maybe you could even talk about your role here, since you're kind of a bonus guest here, but talk about, you know, what you're doing behind the scenes, because what you're doing is very important to all the work that everybody else here is doing. Maybe talk about that, and then how can explain how that works with the council.
Well, I think a lot of these folks, I think have probably heard me talk a time or two, but I'm a recovery plan coordinator for Lower Columbia River Salmon and Steelhead. And I try to look at things not necessarily at the project level, but maybe at a reach scale. And even actually, I look at things at the issue. But when I would talking about habitat with folks, we look at the reach scale. And I've worked with Rachell and John, and we've looked at that upper South Scappoose as a way to think about how we might promote passage in an area that we're probably going to be pretty critical into the future. And so I'm there, and when folks are looking at developing, you know, these big ticket packages of projects or planning, I kind of, when it kind of starts lining up with what we think is probably the most critical pieces for the recovery plan or recovery at a basin level, I often do a lot of assistance, however that may be. And so I think that's important. And then I guess the hardest part to define, I guess maybe it's not even a matter of discussion here, is the service area or of the council. It would be nice if it extended up into Goble Creek, because that's a pretty nasty culvert or crossing we found. But we also recognize that the county is not a flush county to be able to deal with a lot of these issues. So I'm here to assist on these bigger things, and that's a lot of what I do.
Nice.
Yes, thank you so much, Jim. It's nice that you were able to attend. Well, we, as a council, I can say too that we have several fish passage priority projects, especially in that South Scappoose area that we are currently looking at with a couple, a private landowner and then a couple of, or a main municipality. And we will continue those conversations. There are several individuals on here that I will be reaching out to shortly. and we continue to do the work. And I just wanted to again thank you, Dave and John, for presenting today and talking about fish passage. It's so important, and everybody that attended. These partnerships are how we get this on the ground work done. So thank you, everybody.
Awesome. Thanks, Rachell.
I hope everybody has a good evening.